Semiconductor chips. This minute technology wonder is also known as integrated circuits, ICs, or microchips, and is the foundation and the brain of modern technologies. The term semiconductor refers to a material, typically silicon, that can be altered to conduct electrical current, block its passage. Silicon is widely used because it is abundant, cheap, and easy to work with. Electronic components such as transistors and resistors are etched onto the material in layers, along with intricate connections that link components together and facilitate the flow of electric signals. In small quantities, transistors are used to create simple electronic switches. In large number, they are used to create microprocessors where millions of transistors are embedded into a single IC. The latest AI superchips, the GTC Supercard by NVIDIA, has around 208 billion transistors. Semiconductor chips normally fall into three broad categories: logic chips, memory chips, and DAO. The logic chips does all the heavy lifting, processing the instruction and data that were fed onto the device. The most widely used are the CPUs, the GPUs, and neural net processors. Memory chips are designed to store data. The DRAM is a common example of a memory chip. Another type of chips are discrete analog and other chips. Since the first semiconductor IC was built in 1958 by Jack Kilby, applications for chips have been expanding rapidly. Today, it is used in various equipment and gadgets that power our technology era and shape the way we humans live, work, learn, and play. The development of cutting-edge semiconductor is necessary for the advancement of rapidly developing technologies like artificial intelligence, IoT, 5G and 6G communications, and quantum computing. Modern military and space communication and other warfighting technologies are increasingly enabled by the advancement in AI technologies and advanced chips. This makes the semiconductor chips so crucial and of national interest. The AI chips are getting increasingly important to support AI technology applications in various fields. AI chips differ from normal chips by the way they are packaged. CPU has a number of powerful cores in the chip processor that process information in sequence, one calculation after another. And AI chips, on the other hand, has more cores that run in parallel so they can process faster. These cores are especially designed to run AI calculations. Two different types of AI chips: training and inference. Training is where an AI model is fed millions of examples of something. More chips are used for the training process. The inference chips uses the info to generate new info based on the data collected during the training process. Based on data from Statistica, the AI chip market revenue worldwide in 2003 exceeded $53 billion. And in 2022, this figure is expected to be more than 71 billion, and in 2025, almost 92 billion US dollars. Why are the semiconductor chips so important? Semiconductors are the fourth most traded product in the world behind crude oil, motor vehicle parts, and refined oil. The industry is among the most critical industries worldwide. In 2019, 60% of semiconductors produced were for smartphones, personal computing, and data center and server markets. It is expected that this segment will generate a revenue of almost 390 billion US dollars in 2025, according to Statistica. World saw how important semiconductor chips are during the COVID-19 pandemic. The semiconductor shortage in 2021 contributed to lost revenue of more than US 500 billion worldwide. Semiconductors are also crucial enablers in green technology, especially in electric vehicles and green energy systems. In a push to reduce carbon emission and fight climate change, these chips play a vital role. Strategic importance in military equipment and modern warfare and communications. The industry is an enabler of tens of trillions of dollars in annual economic activity worldwide. Many cascading events resulted in a severe shortage of semiconductor chips between 2020 and 2023, here illustrated in this timeline. Early 2019, a fire broke out in Ukraine, disrupting the packaging material. Early 2020, ongoing lockdowns in China. March 20, a large cargo ship was stuck in the Suez Canal, blocking passages of ship delivering chips. In March 21, a fire broke out in Renesas Fab Lab in Japan. In December 21, staffing shortages led shipping delays, where 77 ships were backed up waiting to dock. In February 22, ice storms in Texas caused widespread power outages and took a few fabs offline. And in August 2022, the CHIPS and Sciences Act was signed into law. The US economy lost 240 billion due to chip shortage in 2021 alone. 7.7 million cars could not be produced in 2021 by the auto industry. Many other industries were severely affected all around the world. With increasing demand for Gen AI and EVs plus escalating trade war between China and US, it is crucial to strengthen the global supply chain of this valuable product. Some of the biggest and most sophisticated conductor companies in the world, such as ASE and TSMC, are based in Taiwan. In 2023, Taiwan ranks number 2 in IC design market share, leads the wafer foundry and packaging and testing market share. Taiwan foundries, TSMC and UMC alone make up more than 65% of global foundry revenue for Q4 2023. It is also home to the most advanced chip technologies. Taiwan Semiconductor Manufacturing Company Limited, or TSMC. Established in 1987, this company is one of the very few dedicated foundries in the world and also the world's largest. In 2023, TSMC generated US $69.3 billion in revenue, making it the world's largest semiconductor maker by revenue. Together with other Taiwan foundries, they make up 81% of the global foundry business in Q1 2024. Apple and Nvidia are among TSMC's biggest customers. With the advent of TSMC's 3-nanometer chip technology, semiconductor miniaturization has reached a new level of power and energy efficiency in devices. Apple is the leading customer, boasting more than 50% of orders for these 3-nanometer chips. The semiconductor industry supply chain is extremely complex and segmented and international. Production process, which can take 4 to 6 months, involves more than 500 discrete stages ranging from specialized design software to fabrication plants and dedicated test facilities. The supply chain can cross as many as 70 international borders before reaching the final customers, as illustrated here in this diagram. Semiconductor manufacturing process comes in 3 steps, which is design, fabrication, and assembly and test. The design stage includes R&D and electronic design automation and intellectual properties. This sector is led by a US company with more than 40% of the global market share. Chip design is a critical stage of the supply chain as designing the latest cutting edge chips would be impossible without appropriate software. Fabrication. This sector includes suppliers of fabrication material, equipment, and wafer fab facilities. Most of the facilities are around Indo-Pacific region with around 1,200 facilities located here, including the latest sub-10 nanometer wafer fab facilities in Taiwan and South Korea. The next stage would be assembly, test, and packaging ATP, with more than 95% of ATP facilities in the Asia Pacific region, including Taiwan, China, Malaysia, and Singapore. The ability of a SSC to quickly recover and lessen the effects of unforeseen interruptions while being well prepared and responsive is referred to as semiconductor supply chain resilience. This makes it possible for the supply chain operations to return to their previous levels, guaranteeing continuous customer support and preserving the best possible financial results. One research identified three main challenges facing the supply chain: geopolitical tensions, natural disasters, and limited availability of capital equipment for fab construction. These challenges have the most significant influence on the resilience of the semiconductor supply chain. The study also identifies two most important mitigation strategies, one being investing in semiconductor R&D and developing regional semiconductor manufacturing facilities. And number two, diversification of key component suppliers and promoting domestic manufacturing. In August 2022, US Chips and Sciences Act was passed to set aside nearly $50 billion in investment meant to grow US semiconductor manufacturing capacity. Many trade barriers were imposed for chips and related manufacturing sector that come out of China or supplied to China. Due to this US-China decoupling, companies in the semiconductor supply chain are forced to re-evaluate political and market conditions and co-evolve with other players. Geopolitical policy interventions have given rise to policy changes in many countries to address the supply chain vulnerabilities. South Korea, Japan, India have also announced similar measures. The EU launched European Chip Act in September 2023, a framework to increase EU's market share to 20% by 2030. Malaysia also launched its national semiconductor strategy to increase its market share in the sector. A third-party manufacturer can even improve their strategic and competitive advantages despite political disruption in international markets if they adapt to decentralize and review their strategies in manufacturing locations to co-evolve with policy changes during the US-China decoupling, as reported in a research by Hongzi Gao. To navigate the US-China chip war, TSMC has embarked on a global expansion into the US, Japan, and Germany. 3 fabs in Arizona are being built, 2 fabs in Kumamoto, Japan, and 1 fab in Dresden, Germany. Other foundries in Taiwan, such as UMC and PSMC, are also expanding globally, partnering with other governments and private companies. While the challenges facing the global semiconductor supply chain are significant, the environmental sustainability of the industry must also be taken into serious consideration since this is an energy and water-intensive industry. Ultra-pure water, which is hundreds of times purer than drinking water, is used in wafer production. An average chip manufacturing facility can require up to 10 million gallons of ultra-pure water per day, equivalent to the daily water uses of 33,000 US families. The semiconductor industry is a crucial sector in the global economy. The demand for semiconductor chips will continue to accelerate due to technological advances in many sectors and the demand for greener energy alternatives. The supply chain resilience of this valuable product must be regularly reviewed to safeguard its supply. Effective strategies need to be implemented by the semiconductor supply chain to ensure the resilience of this industry and to meet sustainable development goals.